the last thing I want to do with this semester is touch on one last little topic. Not so much for our work this semester, so I don't think we're going to have to worry about this for our upcoming exam. But I did want to talk about this because I think you might actually need this as you go forward into other coursework. It has to do with solving these trigonometric equations. What if this is not one of the special angles, the square root of 3 over 2? What if it's not pi over 6? What if it's not one of the quadrantal angles, 0, 1, or negative 1? What if it's a more random kind of, what if it's just a garden variety angle? That's what we're going to do. We'll talk about that a little bit. The key is you're going to need a calculator. So anytime it's not one of the special angles, for our purposes, the only way to solve that is with a calculator. So I have my calculator here. We're going to solve these in degrees from 0 to 360. So make sure your calculator is set in degree mode. You could just as easily solve these in radian mode. I'm going to solve these in degree mode. And so here we have. So the good news is some of this is the same, but there's enough of it that's different that you need to be sort of on your guard. So first piece is, here's the equation. As usual, isolate the trigonometric function. Get a basic equation. So isolate the trig function. I'm going to move this over here. Subtract the 5 across. So I have 7 sine of theta is equal to negative 3, which says sine of theta is now equal to negative 3/7. And so now we have isolated the trigonometric function. Same now as before. Quadrant check. Well, where is sine negative? Where is sine negative? Sine is negative in quadrants 3 and 4. So we're going to have a quadrant 3 solution, and we're going to have a quadrant 4 solution. So we're going to have theta equals, right? So the next piece is, after we do quadrant check, then we do reference angle. So reference angle. Now the difference here, before we found the reference angle from the special triangles. 3 over 7 is not one of the special values. So we need to find this using the calculator. And now, something's going to come into play that we've been saying all along and it hasn't seemed like a big deal. The only place we use this negative sign is in determining the quadrants. And I've said this every time, and now, finally, it's going to come into play. Once you have found the quadrants, it is as if this negative sign is no longer here. When you're searching for the reference angle, in particular, when you're searching for the reference angle, this negative sign is ignored. That makes a difference in some of the work we're going to be encountering. The simplest way to play this is once you've found the quadrants, ignore the negative sign. So if we want to find the reference angle, we're going to do this. We're going to say sine of theta. Ignore the negative sign. Ignore the negative sign. Once you've done the quadrant check, ignore the negative sign. This is 3/7. And what we'll do is, you don't have to write this every time, but this is what's happening. We're going to take sine inverse of sine and sine inverse of 3/7. So we take sine inverse of both sides of this equation. You do not need to write this piece out because you know this is going to cancel. On the left-hand side, we have theta is equal to, we need sine inverse of 3/7. And so, go to the calculator. Clear, clear. I need sine inverse, which is seconds, sine inverse, open parenthesis. I have 3 divided by 7, close parenthesis, and equals. And what I have is, and let's use 1 decimal. So we're going to round this to 1 decimal place. I have 25.37. I'm going to say this is theta reference. Theta reference is I have 25.4. Theta reference is 25.4 degrees. Theta reference is 25.4 degrees. Whatever the calculator gives you is not theta, it is theta reference. The calculator, when you use sine inverse, cosine inverse, tangent inverse, the calculator gives you the reference angle, not the angle itself. You need to take the reference angle and place it in the appropriate quadrants to find the values of the theta that we're looking for. And so we're going to have a quadrant 3 solution. If this is quadrant 3, here's 25.4. Question is, what is that angle? That angle is 180 plus the 25.4. So if I take 180 plus 25.4, I have 180 plus 25.4. Well, pretty obviously that's 205.4 degrees. And then quadrant 4. There's the reference angle, 25.4 degrees. There's theta. That's what we're looking for. That is one complete revolution, but you subtract off the 25.4. This is 360 minus 25.4. So I need 360 minus 25.4, and I have 334.6 degrees. Make sure you put degrees, and those are my two solutions. So isolate just like before, quadrant check just like before, ignore the negative sign just like before, find the reference angle, but finding the reference angle comes from the calculator with the inverse sine, inverse cosine, inverse tangent function. Once you find the reference angle, place in the appropriate quadrants to find the two solutions. So what I'll do next is just several examples of this so you get a feel for it.